Okay, guys, we're looking at our exam review. So this is broken up into 7 different sections. It's not chronological like the course was, but I tried to group things that were similar. But some things, feel like chronological. Factoring is what we started with. So you're going to need to be solid on all the methods of factoring. So those methods of factoring, we had the greatest common factor. We had the difference of two squares. And then we had factoring of trinomials, and then we had grouping, okay? So most of these methods have come back and forth at different times of the semester. You just need to be solid with all of those. The greatest common factor, if the greatest common factor is applicable, you want to do that first. That is, if these terms share something in common. What do these two terms share in common? It looks like numerically they share a 3. If I look at the x's, I have 2 in the first term, 1 in the second, so it looks like they share at least one x. If I look at the y's, they both share one y. And then I just go backtrack it. What do I multiply to 3xy to get 12x squared y? So what do I multiply 3 by to get 12? That is a 4. What do I multiply x by to get x squared? That is an x. What do I multiply y by to get a y? That's a 1. Minus. What do you multiply 3 by to get a 3? That's 1. X by to get an x, that's 1. Y to get a y, that's 1. And then you have a z that is left by itself. So the answer is 3xy, 4x minus z. Then we moved into the difference of squares. This is the only factoring method that there is a formula that you apply and it works every time. So if you have x squared minus 4, both of those are perfect squares. This factors into x minus 2. This is x minus 2, x plus 2. So you take the square root of both terms and you factor it in this fashion. Now sometimes what it's illustrating here is you have to do this method more than once. So x to the 4th minus 1. That is x squared minus 1 times x squared plus 1. Both of those being perfect squares. And then you look at it and see, wait, I'm not done. That is also the difference of squares. That's x minus 1, x plus 1, and there is nothing to factor the sum of two squares. So that's my final answer there. And then you'll run into problems like it illustrates here, where you've got a common factor. So if you look at 8x squared minus 18, those are not perfect squares, but it looks like I can factor out a 2. So if I factor out a 2, this is 4x squared minus 9. Now, what I see inside the parentheses, those are both perfect squares. So this is 2 times 2x minus 3 and 2x plus 3. That's the final factorization for that. Factor by grouping, we've done that quite a bit, so I'm not going to go through that here. We'll do a few exercises, but you should be very familiar with factor by grouping. And then the other thing that's come up repetitively in the course is factoring of quadratics. When you have something that looks like x squared plus bx plus c, the key is in front of the x squared is a 1. All you have to do is to find two numbers that multiply to give you c and add to give you b. So for example, if I'm looking at this, I need two numbers that multiply to 15 and add to negative 8. Okay, so if they multiply to 15, the only choices are 1 and 15, 3 and 5. The only way to make those get to a negative 8 is if I use a negative 3 and a negative 5. So my answer is just going to be x minus 3, x minus 5, and I'm done with that factorization. Now, where it gets a little bit different is when you see something where the number in front of the x squared is not a 1. Here I have to find two numbers that multiply to give me, you multiply these first and last numbers, multiply to negative 24 and add to 10. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then they start to repeat. The only way that I can multiply these and get a negative 24 and a positive 10 is going to be a negative 2 and a 12. Those numbers multiply to negative 24 and they add to 10. So I rewrite this problem as 8x squared minus 2x plus 12x minus 3. Then I factor by grouping. Common factor here is 2x. And then I'm left with 4x minus 1 plus, common factor here is 3. 4x minus 1. Answer is 2x plus 3. 4x minus 1. Okay, so we've done quite a bit of that, the grouping part in the course. So that just leads us to sample problems. Okay, you got to look at everything. When I see two terms, it's either the difference of two squares or greatest common factor. Okay, I see greatest common factor here. Okay, so if I look at 8 and 24, I can pull out a common 8, and then they have an A in common, and they have a C in common. What do you multiply 8 by to get 24? That's 3. A to get A, that's 1. And then there's also a B in there. What do I multiply C by to get C squared? Okay. Minus. What do you multiply 8 by to get negative 8? That's going to be a negative 1. A to get A squared, and C to get C, and there we are. So that is the factorization. Look at the next one here. If it's two terms, it's either difference of squares or common factor. These are not perfect squares. Let's factor out the greatest common factor. If I factor out a 2, I get 9x squared minus 1. Now, what's in the parentheses is perfect squares. So this is 2, 3x minus 1, 3x plus 1. So I had to use two methods here. I had to use the greatest common factor and the difference of squares. So it's very common in factoring that you have to use multiple methods. A squared plus 4a minus 21. Well, if this factors, I'm going to look for two numbers that multiply to negative 21 and add to 4. What are the factors of 21? 1 and 21, 3 and 7, and that is it. Is there a way to get a 4 out of these? Well, if I used a negative 3 and a positive 7, those multiply to negative 21 and add to 4. That's my answer. Instead of x. This is a minus 3, a plus 7. Next one, 2x to the 4th minus 32. I can tell that both of those I can factor a 2, x to the 4th minus 16. That's greatest common factor. What's inside the parentheses is a perfect square. So this is 2, x squared minus 4, x squared plus 4. Always be on the lookout when you have two things subtracted. Is that the difference of squares? Yes, that is. So this final answer is 2, x minus 2, x plus 2, x squared plus 4. And that's my final factorization. So this one required greatest common factor and difference of squares 2 times to get to the answer. If I look at the next one, if this factors, I'm looking for two numbers that multiply to 24 and add to 14. What are the factors of 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. The only way to add those and get a 14 is with the 2 and the 12. So this is 8x squared plus 2x plus 12x plus 3. Factor by grouping now. What do these have in common? It looks like a 2x, and you're left with 4x plus 1 plus 3, 4x plus 1. Your answer is 2x plus 3 times 4x plus 1. So this one was factoring a trinomial where the first term was not a 1 in front of the x squared. This one, I see 4 terms. There's only one method I ever taught you with 4 terms. It's grouping. It either works or it doesn't. So let's try grouping on this guy. So let's look at the first 2 terms and the second 2 terms. So what do the first 2 terms have in common? That is an x squared. That leaves me with 2x plus 3. With grouping, the next thing you do is, Whatever that sign is, you copy it down. That's a minus sign. Okay. What do the 8 and the 12 have in common? It looks like a 4. So negative 4 times what number equals a negative 8x? That's going to be a 2x. Negative 4 times what number is 12? That's a positive 3. Now I see that I've got x squared minus 4 times 2x plus 3. I'm not done because now I see x squared minus 4 is the difference of two squares. This is x minus 2, x plus 2, 2x plus 3. Let's look at this one. This is factoring a trinomial. I need two numbers that multiply to 27 and add to negative 12. Factors of 27 are 1 and 27 and 3 and 9, and that is going to be it. So I can do a negative 3 and a negative 9. Those multiply to 27, add to negative 12. So this answer is just x minus 3, x minus 9. 4x squared minus 9y to the 4th. Looks a little complicated, but both of those things are perfect squares. So this is 2x minus 3y squared times 2x plus 3y squared. Number 9. How do I factor this? Well, I need to find two numbers that multiply to give me a 36 and add to give me a negative 13. Factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9. The only way to get a negative 13 out of those guys is if I had a negative 4 and a negative 9, and those would multiply to positive 36. So this is 6x squared minus 4x minus 9x plus 6. Now we factor by grouping. The first two terms have a 2x in common, so that leaves me 3x minus 2. Copy down that minus sign, then I can factor out a 3, and that leaves me 3x minus 2. This answer is 2x minus 3, 3x minus 2. Number 10, this is the difference of two squares. So this is 2x minus 4 times 2x plus 4, okay? And that's it. So this is the first section of the review, a review of factoring, okay? So you have homework problems to do, homework problems to review. This was just pulled from the factoring, but you also have quizzes to look over. So I'm hoping that you can work through some of this without looking at the video, but it is there for you to take a look.